In this video, we are going to be looking at how you solve equations when there are variables on both sides. And this is the last video in our video series from our book of solving equations. So for solving with variables on both sides, it's actually an extension of what we did last time with those multi-step equations. So this is just some more examples of when you need to move variables to one side. So more examples. So it's not actually a different thing. Now, you've actually solved problems like this already with your hands-on equations set. It's basically when you did those legal moves where you removed the same number of pawns from both sides. So you were moving the pawns from one side to another, isolating those variables, making sure that all of them were on one side of your equation in order to figure out the value of the pawn. Okay, so in this video, long story short, we're going to be getting into how do you show that algebraically. Okay, so we're still going to go through our steps, our multi-step equations steps. So first, I'm gonna think back to the mnemonic device. Don't call me after midnight. DCMAM. So D is for distribute. So I'm gonna see, are there any parentheses that I need to distribute the multiplier? Nope. So I'm gonna go on to my next one. I'm gonna combine like terms. So do I have a whole bunch of k's over here and constants on one side, or vice versa? Nope, I just have k's and constants, and on the other side, k's and constants. So I need to move my variables to one side. So right now, I have pawns over here and pawns over there. Now, you have more pawns on this side than that side. So imagine 5 little ones are stacked up there and 8 little ones are stacked up there. Which one does it make the most sense to remove? If you said these guys, you are absolutely right. It makes way more sense to remove those 5 pawns. So if I take away 5 pawns, or 5k from that side, I need to maintain balance on my scale, so I'm going to take away 5 pawns, or 5k over there. So that's how you would notate that. Subtract 5, subtract 5. So you're just writing down, this is the legal move that I'm doing to get my balance scale. All right, so I'm going to bring down my -2, 8k minus 5k, I'm left with 3k, and I bring down my +4. Okay, so my next step, I'm going to add or subtract by my constants. So right now, here's my variable, and it's on this side. Usually we have it over on that side, but it doesn't matter. Mathematically, it means the same thing. So I want to get rid of this +4. So to get rid of +4, I need to subtract 4, -4. And what I do to one side, I need to do to the other, -4. All right, so this term gets eliminated. I bring down my 3k equals -2 minus 4 is going to be -6. And I want to now multiply or divide by my coefficient. So that means right now, k is being multiplied by 3. In order to undo multiply by 3, I need to divide by 3. Divide by 3, both sides. All right, so 3k divided by 3 is just plain old k, which is equal to -6 divided by 3 is going to be -2. All right, now you have -2 is equal to k, but oftentimes when we put things in our final answer, what we'll do is I'll just kind of sneak it over here. We put the k on the opposite side, or the variable on this side. K is equal to -2. All right, so let's do another one together. -3m plus 2 equals 6m minus 7. All right, so again, we want to get all of the m's on the same side. So right now we have some negative m's over here, and we have some positive m's over there. So let's eliminate these negative m's. So if I have -3m, in order to undo it, I want to do plus 3m. Plus 3m, because what I do to one side, I need to do to the other. Now I know what you're thinking. Wait a minute, I thought that this was multiply by -3. Why aren't you dividing by -3? Because you don't want to just get rid of the coefficient, you want to get rid of the whole term. So to get rid of the whole term, it needs to be, you need to do the opposite. So think of it like 3 little negative pawns. If you want to get rid of 3 negative pawns, you gotta put 3 positive pawns in their place, and then they cancel them out like a 0 pair. Okay, so those terms get eliminated. And I'm going to then bring down my plus 2, so that's 2, is equal to 6m plus 3m, that's 9m, and I bring down my minus 7. Okay, next thing I'm going to do is I'm going to check to see if I need to move all my variables, or see if I need to combine any of those terms, so I'm good there, and now I just need to get rid of this, this constant. So right now it's minus 7, so in order to undo that, I need to add 7, or plus 7. What I do to one side, let's do it to the other, because I want to maintain balance on my scale, right? Okay, I'll do a horizontal line there. And I'm going to bring down my 6m, that term has been eliminated, equals 7 plus 2 is 9. Oh, goodness gracious. Let me go back. 6 plus 3 is not 6. It is 9. What am I doing? Okay, so 9m minus 7, which means then this should be 9m there. Goodness gracious. All right, now if we had been doing this live in class, you guys would have pointed that out to me. Okay, so we have 9 equals 9m. And in order to get rid of that multiplier, 9 times m, we need to divide by 9 and divide by 9. So 9 divided by 9 is 1. 9m divided by 9 is just plain old m. So m equals 1. Then we can then do like what we did over there, is we can flip it the other way. M equals 1.